Step outside on a clear moonless night, far from the suffocating glow of city lights. If you look toward the constellation of Cassiopeia, just below its W-shaped throne, you might notice a faint, elongated smudge of pale light. It does not look like much. A trick of the eye, perhaps. A wisp of high-altitude vapor. But you are not looking at a cloud. You are looking across an abyss so incomprehensibly vast that the human brain is biologically incapable of grasping its true dimensions. That faint smudge is the Andromeda Galaxy, our closest galactic neighbor. We use the word neighbor to comfort ourselves. It implies a sense of community, a cosmic proximity that makes the dark feel a little less lonely. But this is a comforting lie. The distance to Andromeda is not merely a number written in an astrophysics textbook. It is a physical, terrifying reality of empty space. A void so profound that light itself, the absolute speed limit of the universe, tearing through the vacuum at 186,000 miles every single second, takes 2.5 million years to cross it. When the photons from that pale smudge finally strike your retina tonight, you are not seeing Andromeda as it is. You are receiving a fragmented, ancient transmission from an era before our species even existed. When that light began its solitary journey, the Earth was in the grip of the Pleistocene epoch. Homo habilis was barely learning to strike stones together to make the first primitive tools. For 2.5 million years, while human history played out its brief chaotic prologue, while entire species went extinct and continents drifted across the mantle, that light was silently crossing the dead expanse of intergalactic space. Let us strip away the clean, clinical abstraction of light years. Imagine scaling the entire Milky Way galaxy, with its hundreds of billions of stars and its sprawling spiral arms, down to the size of a single solitary grain of sand resting on the palm of your hand. At that unimaginable scale, where our entire solar system is infinitely smaller than a subatomic particle, Andromeda would be another grain of sand resting roughly a foot away. And between your palm and that distant grain, nothing. A silent, crushing ocean of absolute vacuum, devoid of matter, devoid of warmth, indifferent to life. We look up and see a crowded cosmos, but astronomy is a science of ghosts. We are surrounded by phantoms of the deep past, separated from us by a gulf of nothingness that shatters human intuition. To understand the true distance to Andromeda is to confront the terrifying isolation of our own reality. If you find yourself drawn to the uncompromising mechanics of the cosmos, if you seek truth in the dark, rather than the comfort of terrestrial illusions, subscribe and join us on this journey. We are going to deconstruct the sheer scale of the void, step by agonizing step. To understand the profound terror of the distance separating us from the Andromeda Galaxy, we must first recognize a fundamental flaw in our own biology. The human brain is an exquisite survival engine, forged over millions of years on the savannas of Pleistocene Africa. It was engineered by natural selection to calculate the trajectory of a thrown spear, to judge the distance to a predatory cat hidden in the tall grass, and to navigate the immediate three-dimensional topography of a terrestrial environment. Our neurological architecture is perfectly calibrated for the local, the immediate, and the tangible. It is entirely unequipped to process the architecture of the void. We are a species bound to the dirt, looking up at the infinite, trying to measure an ocean with a ruler designed for a puddle. Because of this biological limitation, our intuition betrays us the moment we look at the night sky. When you tilt your head back and observe the stars, your brain instinctively flattens the cosmos. It paints the universe onto a two-dimensional dome. A star sitting 4 light-years away appears to rest on the exact same plane as a galaxy millions of light-years distant. They are just pinpricks of varying brightness on a black canvas. For the vast majority of human history, this optical illusion was accepted as absolute reality. The ancient astronomers looked at the glittering canopy and assumed the universe was small, orderly, and deeply comforting. They envisioned a celestial sphere, a physical shell encasing the Earth, rotating with mechanical precision. In this archaic model, the stars were close. They were intimately tied to our destiny. The universe was a cozy, claustrophobic theater built exclusively for the human drama. Shattering that dome was not a sudden revelation. It was a slow, agonizing process of mathematical deduction that tore humanity away from the center of creation. The first tool we used to crack the illusion was a geometric concept known as stellar parallax. To understand parallax, imagine sitting in a speeding train at night. If you look out the window, the fence posts right next to the tracks appear to blur past your vision in a fraction of a second. But the distant mountains on the horizon barely seem to move at all. The closer an object is to the observer, the more its apparent position shifts as the observer moves. Astronomers realized they could use this exact principle to measure the distance to the stars. The Earth travels in an elliptical orbit around the Sun, covering a baseline of 186 million miles from one side of its orbit to the other. By photographing a specific star in January and then photographing that exact same star 6 months later in July, astronomers could measure how much the star appeared to shift against the static background of deeper space. Through the cold, unyielding logic of trigonometry, that tiny angle of shift could be translated into physical distance. But there was a problem, a terrifying problem, that hinted at the true crushing scale of the cosmos. The stars are so unfathomably far away that the parallax shift is almost imperceptible. Even for Proxima Centauri, the closest star to our solar system, the angle of shift over a 6-month period is less than 1 arcsecond. To visualize how infinitesimally small that is, imagine looking at the width of a human hair from a distance of 60 feet. That is the angle astronomers were trying to measure using crude brass instruments and early photographic plates. For decades, the universe resisted our attempts to map it. We could measure the distance to our immediate stellar neighbors, but beyond a few hundred light years, the angles became too small to detect. The parallax method hit a mathematical brick wall. The deeper universe remained completely cloaked in an impenetrable fog of ignorance. By the year 1920, astronomy was caught in a state of profound philosophical tension. Humanity was staring into the dark, completely blind to its own scale. This tension culminated in an event known as the Great Debate, held at the Smithsonian Museum of Natural History in Washington, D.C. Two prominent astronomers, Harlow Shapley and Heber Curtis, faced off to argue the fundamental nature of reality. Shapley argued for the small universe. He believed that the Milky Way galaxy, our sprawling spiral of dust and stars, was the entirety of the cosmos. Everything we could see, including those mysterious glowing clouds called spiral nebulae, was contained within the borders of our own galaxy. It was a model that offered a strange sense of security. It meant the universe had a boundary. It meant the dark had an edge. Heber Curtis argued the opposite, and his theory carried with it the heavy weight of existential dread. Curtis proposed that those faint spiral nebulae, like the one found in the constellation of Andromeda, were not gas clouds inside our galaxy. He argued they were island universes, entirely separate galaxies, massive collections of billions of stars, adrift in a void so expansive it defied human comprehension. If Curtis was right, the Milky Way was not the universe. It was merely a single insignificant speck of dust floating in a black ocean without a shore. But neither man could prove their theory. The debate ended in an intellectual stalemate. The tools of the era simply could not measure the abyss. The fog remained. The breakthrough did not come from a massive telescope or a dramatic moment of discovery on a mountaintop. It came from a quiet, poorly lit room at the Harvard College Observatory, driven by the meticulous, relentless labor of a woman whose name should be etched into the foundation of modern physics, Henrietta Swan Leavitt. In the late 19th and early 20th centuries, women were generally not allowed to operate the great telescopes. Instead, they were employed as human computers, tasked with cataloging and analyzing the thousands of glass photographic plates captured by the male astronomers. It was grueling, solitary work. Leavitt spent her days staring through a magnifying loupe at fragile glass negatives, measuring the brightness of thousands of individual stars, recorded as tiny black dots on a clear background. She was specifically studying a group of stars in the Magellanic Clouds, a pair of dwarf galaxies visible in the southern hemisphere. Leavitt became obsessed with a specific type of star known as a Cepheid variable. Unlike our Sun, which burns with a steady, relentless consistency, Cepheid variables are unstable. They physically expand and contract, breathing like colossal, dying lungs. As they swell and shrink, their brightness pulsates in a rhythmic, predictable pattern. Over days or weeks, they grow intensely luminous, then fade, then grow luminous again. As Leavitt catalogued these pulsing stars, her brilliant mind recognized a hidden mathematical architecture buried in the raw data. She noticed that the brighter a Cepheid variable was, the longer it took to complete one cycle of pulsation. A star that took 30 days to pulse was inherently vastly brighter than a star that took only 3 days to pulse. This was not a random coincidence. It was a hard, unbreakable physical law. Because all the stars she was observing in the Magellanic Clouds were roughly at the same distance from Earth, she realized that their apparent brightness on the glass plates directly correlated with their actual, intrinsic luminosity. This discovery, known as the period luminosity relationship, was the master key that unlocked the universe. Henrietta Swan Leavitt had just discovered the cosmic standard candle. To grasp the magnitude of this discovery, imagine standing on a pitch-black coastline at midnight, looking out over a dark, raging ocean. Somewhere in the distance, you see the faint, rhythmic, sweeping beam of a lighthouse. If you do not know how bright the lighthouse bulb actually is, you have no way of knowing how far away it is. A dim light a mile away looks exactly the same as a massive, blinding searchlight 10 miles away. You are blind to the depth of the field, but imagine you somehow know with absolute mathematical certainty the exact wattage of that distant lighthouse bulb. Once you know its true intrinsic brightness, the problem is solved. You can measure how faint the light appears to your eye, apply the inverse square law of light, which states that light dims predictably as it spreads out over a distance, and calculate exactly how many miles of dark water lie between you and the tower. Henrietta Leavitt gave astronomers the wattage of the stars. If an astronomer could find a Cepheid variable anywhere in the universe and simply time how long it took to pulse, they would know its exact, true brightness. By comparing that true brightness to how faint it looked through a telescope, they could measure distances across the void that parallax could never touch. She handed humanity a tape measure capable of stretching across the infinite. Tragically, Leavitt died in 1921, completely unaware of how violently her discovery was about to tear the fabric of human understanding apart. She provided the mathematics, but it fell to another astronomer, Edwin Hubble, to look through the glass and witness the horror of the true scale. In the autumn of 1923, Edwin Hubble was working at the Mount Wilson Observatory in the San Gabriel Mountains of Southern California. He had command of the Hooker telescope, a terrifyingly massive instrument. Its primary mirror was a solid disc of silvered glass 100 inches across, housed in a cathedral of steel and gears that groaned and shifted as it tracked the night sky. Observing at Mount Wilson was not a glamorous endeavor. It required sitting for hours in the freezing, unheated dome, in absolute darkness, manually guiding the massive machinery to keep the crosshairs perfectly aligned on a target as the Earth slowly rotated beneath it. It was physical, exhausting labor, isolated on the freezing peak of the mountain. Hubble was aiming the great 100-inch mirror at the Andromeda Nebula, that faint smudge in the constellation of Cassiopeia. He was hunting for novae, stars that suddenly flare up in brightness. He took a long exposure photograph, a glass plate labeled M314. When he developed the plate in the chemical baths downstairs, he noticed a tiny speck of light. He initially marked an N next to it for nova. But as he compared plate M314 to older photographs of Andromeda taken days and weeks prior, the truth hit him with the force of a physical blow. The star was not a nova, it was pulsing. It was growing brighter, fading, and growing brighter again in a distinct, measurable rhythm. He crossed out the N with a red pencil and wrote 3 letters that would alter the trajectory of human history: VAR, followed by an exclamation point. It was a variable star, specifically a Cepheid variable, the exact type of cosmic lighthouse Henrietta Leavitt had decoded. Hubble now had everything he needed. He timed the pulsation of the star, which we now call V1. He used Leavitt's mathematical law to determine its true blinding luminosity. And then he calculated the distance. The mathematics did not yield a comfortable number. The equation did not place the Andromeda Nebula within the familiar claustrophobic borders of the Milky Way. When the final variable locked into place, the universe, as humanity understood it, violently fractured and fell apart. The distance to Andromeda was not thousands of light years. It was not tens of thousands of light years. The cold, impassive mathematics revealed a distance so aggressive, so utterly hostile to human intuition, that it permanently relegated our entire galaxy to the status of a microscopic island. The light from that single pulsating star had not been traveling for a few millennia. It had been traveling across a dead, frozen vacuum for 2.5 million years. In that single moment in the freezing dark of the Mount Wilson Observatory, the great dome of the ancient sky shattered outward into an infinite, terrifying expanse. The universe was not a small, orderly sphere. It was an endless, chaotic abyss filled with billions of other galaxies, all separated by gulfs of nothingness so severe they make a mockery of human existence. Hubble proved that the Milky Way was not the universe. We were just stranded on one lonely raft, adrift in a silent ocean of unimaginable scale. And as we stare out across that ocean toward our nearest neighbor, the raw mechanics of that distance present a reality far darker than any fiction. The space between the Milky Way and Andromeda is not merely an absence of things. The concept of a true, pure vacuum is a mathematical fiction, a clinical abstraction that exists only on the chalkboards of theoretical physicists. In reality, the void is a physical environment, and it is overwhelmingly hostile. The 2.5 million light-years separating our galaxy from its nearest neighbor are filled with a tenuous, freezing mist of primordial gas. Astrophysicists refer to this as the warm-hot intergalactic medium. Imagine isolating a volume of space exactly the size of an average terrestrial living room. In the atmosphere of Earth, that specific volume contains trillions upon trillions of violently colliding gas molecules. They provide atmospheric pressure, they transmit the mechanical waves we interpret as sound, and they sustain biological life. Now, isolate that exact same volume in the dead space between our spiral arms and Andromeda. In that entire living room, you might find a single solitary atom of hydrogen, perhaps two. They are so unimaginably isolated that they might drift for tens of millennia without ever colliding with another particle. This is an environment of sensory deprivation scaled to a cosmic level. If you were deposited into this intergalactic expanse, the silence would be absolute, because there is no medium dense enough to carry sound. You would be submerged in a temperature hovering just a few degrees above absolute zero, the theoretical bedrock where thermodynamic motion itself begins to cease. This vast, freezing ocean enforces a strict, unbreakable quarantine on the universe. We possess a biological bias to think of reality as something happening simultaneously. You observe the world around you and assume the events unfolding are occurring in an objective, present tense. But modern physics violently rejects this intuition. The present tense is a strictly local, fabricated phenomenon. The speed of light is not simply a measure of how fast photons travel through a vacuum. It is the absolute speed limit of causality itself. It is the maximum allowable rate at which one piece of the universe can physically affect or communicate with another. Think of it as the latency of a global server network, but hard-coded into the bedrock of reality. If a computer in Tokyo sends a data packet to New York, there is a measurable physical delay as the signal routes through fiber optic cables. On a cosmic scale, the latency between the Milky Way and Andromeda is 2.5 million years. If the supermassive black hole at the core of Andromeda were to suddenly become highly active today, triggering a cataclysmic burst of quasar radiation that sterilized the inner galaxy, we would have absolutely no way of knowing. The blinding light and the gravitational ripples of the event would begin their relentless march across the void, strictly bound by the speed of causality. For 250,000 human generations, the night sky of Earth would remain completely unchanged. We would continue to look up at a ghost, studying a galaxy that has already been radically altered. We are trapped inside a temporal bubble, perpetually disconnected from the true current state of the cosmos. To truly internalize the agonizing scale of this isolation, we must trace the physical journey of the light that reaches our observatories. A photon is born deep within the crushing nuclear furnace of an alien star in one of Andromeda's sprawling spiral arms. It is forged in an environment of unimaginable pressure, where hydrogen atoms are violently fused into helium. From the exact moment of its creation, the photon begins a chaotic, randomized journey toward the surface of the star, bouncing off dense layers of plasma in a process known as a random walk. It is absorbed and re-emitted countless times, taking tens of thousands of years just to escape the stellar core. When it finally breaches the photosphere, it is violently ejected into the vacuum. It leaves the gravitational well of its parent star. It navigates past rogue, wandering planets and the expanding shockwaves of dead supernovas. It breaches the outer galactic halo, slips past the ancient globular clusters that orbit the galaxy's edge, and plunges into the intergalactic void. For the next 2.5 million years, that photon experiences absolutely nothing. According to the theory of special relativity, at the exact speed of light, time dilates to infinity and physical distance contracts to zero. From the perspective of the photon, the journey does not take millions of years. From its reference frame, the moment of its violent emission and the moment of its eventual absorption occur in the exact same mathematical instant. It does not experience the passage of time, it does not age, but from our static planetary reference frame, it is enduring an epic silent odyssey. It travels across the dark, unyielding ocean, carrying a microscopic, uncorrupted fragment of information about the star that birthed it. While that photon is in transit, the Earth is subjected to violent planetary remodeling. Tectonic plates collide, pushing up mountain ranges that slowly erode back into dust. Glacial sheets advance to suffocate entire continents, then retreat in cyclical rhythms, driven by slight orbital variations. Entire evolutionary lineages of complex life diverge, flourish, and are permanently erased by extinction events. Through all of this furious, chaotic biological and geological noise, the photon remains in silent, undisturbed flight, covering 186,000 miles every single second. Its journey ends violently against a piece of polished glass suspended in the darkness of Earth's orbit, or resting on a remote, high-altitude peak. Consider the sheer engineering audacity required to capture this exhausted fragment of light. Modern observatories do not use eyepieces for human eyes to look through. They are colossal, precision-engineered photon traps. The photon from Andromeda strikes a primary mirror coated in a microscopic layer of aluminum, polished to such extreme exactitude that if the mirror were scaled up to the width of the Atlantic Ocean, the tallest imperfection on its surface would be a fraction of an inch high. The photon bounces off this parabolic surface, strikes a secondary reflector, and is focused precisely down into a digital sensor array known as a charge-coupled device. Here, the photoelectric effect takes over. The ancient photon slams into an atom of silicon, transferring its remaining energy to knock a single electron out of its orbit. That displaced electron is corralled by microscopic electrical fields, counted by an onboard computer, and translated into a single line of digital binary code. We do not simply look at Andromeda, we meticulously collect its dead debris, one subatomic collision at a time, slowly building a composite image of a phantom. Yet this passive, quiet observation masks a deeply aggressive physical reality. When you look at an astrophotograph of Andromeda, its majestic spiral arms and glowing core appear frozen in time. It resembles an ornate clock resting silently in a museum display. This is the ultimate deception of cosmic scale. The universe is not a static diorama. It is a violently dynamic arena governed by the ruthless, uncompromising dictations of gravity. While the fundamental expansion of the universe is driving the vast majority of distant galaxies away from us at terrifying speeds, stretching their light into longer, redder wavelengths, a phenomenon known as cosmological redshift, Andromeda, is the great exception. When astrophysicists analyze the light from Andromeda, passing it through spectroscopes to break it down into its constituent frequencies, they do not see the red signature of retreat. They see a distinct, undeniable blue shift. The light waves are being compressed. They are physically bunching up as the source plows through the vacuum toward the observer. The void between us is shrinking. The Milky Way and Andromeda are locked together in an invisible gravitational tether, pulling each other across the dark at a velocity that shatters human comprehension. Andromeda is falling toward our galaxy at a staggering speed of 110 kilometers every single second. To put that brutal velocity into perspective, an object traveling at that speed could cross the entire continental United States in less than 40 seconds. Every minute that passes, the distance between our two galaxies closes by over 6,000 kilometers. It is the steady, unyielding rotation of a massive clock gear winding down toward an inevitable collision. We are two leviathans accelerating toward a cosmic impact in an otherwise expanding, emptying universe. The term collision, however, is a terrestrial concept. It evokes images of violent, immediate kinetic energy transfers, crumpling metal and shattering glass. A galactic collision is a slow-motion haunting that takes billions of years to resolve. Because galaxies are composed overwhelmingly of empty space, the individual stars within them will almost certainly never strike one another. If you scaled our sun down to the size of a ping-pong ball, the nearest star to us would be another ping-pong ball located nearly 700 miles away. The spatial geometry makes a direct stellar impact statistically impossible. Instead, the collision is a war of gravitational tides. As Andromeda breaches the dark matter halo of the Milky Way, the invisible architecture that holds both galaxies together will begin to interact and deform. The gravitational drag will warp and distort the delicate, sweeping spiral arms. Millions of stars will be violently ripped from their stable orbits, flung out into the freezing intergalactic void like glowing sparks flying off a massive grinding wheel. Over hundreds of millions of years, the supermassive black holes at the center of each galaxy will find each other. They will begin a terrifying orbital dance, spiraling inward, bleeding off orbital energy by emitting massive ripples in the fabric of space-time itself. The vast, dormant gas clouds of both galaxies will smash together, compressing rapidly and igniting furious firestorms of new star formation. The night sky of Earth, or whatever charred rock happens to occupy this coordinate in the distant future, will be radically transformed. The faint ghostly smudge of Andromeda will grow until it dominates the entire celestial hemisphere, an overwhelming chaotic ribbon of blinding starlight and thick dust lanes that outshines the moon. It will be a sky of breathtaking violence as orbital mechanics tear the familiar constellations apart to forge an entirely new elliptical galaxy. But even this monumental galaxy-destroying event is merely local weather. The Milky Way and Andromeda are just the two dominant gravitational anchors of a small neighborhood known as the local group, which contains a few dozen minor dwarf galaxies. Our local group spans a distance of roughly 10 million light-years across. It seems vast. But as we pull back the objective lens, the true scale of the mystery begins to induce a profound intellectual vertigo. Our entire local group is just a tiny, insignificant subcluster, resting on the extreme outer fringe of the Virgo supercluster, a colossal, sweeping structure containing thousands of individual galaxies stretching across 100 million light-years. And the Virgo supercluster itself is merely one tiny illuminated thread in Laniakea, an immeasurable twisting web of dark matter and galactic filaments that maps the large-scale architecture of the observable universe. We are forced to confront the terrifying ratio of matter to nothingness. If you were to somehow take all the stars, all the wandering planets, all the black holes, and all the glowing nebulas in the entire observable universe, grind them down into a perfectly even atomic mist, and distribute them equally across the total volume of space, the resulting density would be practically indistinguishable from zero. The universe is composed almost entirely of the void. The magnificent spiral galaxies are nothing more than microscopic, glowing impurities suspended in a freezing ocean of dark energy and vacuum. We obsess over the structures because that is what we are made of. We are biased toward the light. But the dominant defining feature of physical reality is not the light. It is the crushing, oppressive distances that separate the light. When we look at a photograph of the Andromeda galaxy, we are the victims of a severe compression of data. The image shows a dense, bright core tightly wound with glowing arms. It looks solid. It looks like an object with mass and surface area. But this is an illusion created by the telescope, compressing millions of years of deeply scattered light into a single, flat, two-dimensional frame. If you were to magically teleport into the dead center of Andromeda right now, into the absolute most densely populated region of its galactic core, you would not find yourself blinded by a solid wall of plasma. You would find yourself in an expanse of profound darkness. The stars would be much closer together than they are in our solar neighborhood, perhaps only a fraction of a light year apart, but the space between them would still be unimaginably vast. The night sky would be brilliant, littered with thousands of stars shining as brightly as the full moon, but it would still be fundamentally composed of empty blackness. There is no escape from the void. It permeates every structure, separating the galaxies, separating the stars, separating the very subatomic particles that construct the illusion of solid matter. And still, despite the overwhelming dominance of empty space, the physical mechanics of gravity refuse to be ignored. The gears continue to turn, 110 kilometers closer every single second. The light we observe today is a relic, an echoing transmission from an era when hominids were just beginning to strike flints together in the dust. By the time the light leaving Andromeda right now finally arrives at our solar system, humanity will either be a multi-planetary species of unimaginable technological scale, or a forgotten layer of radioactive sediment compressed deep within the crust of a dead world. But the light will arrive. The exhausted photons will make the crossing, completely indifferent to the brief, chaotic biological dramas playing out on a single speck of rock. The physics of the approach are absolute. The space between us is a graveyard of light, a 2.5 million year time delay that masks the terrifying truth of our cosmic trajectory. We are staring down the barrel of a slow-motion impact, separated by an ocean of nothingness that defies human sanity to map. And as we refine our orbital instruments, as our mathematicians peer deeper into the equations of the void, we begin to realize that the fundamental rules governing this space are hiding a much darker paradox. When we observe Andromeda closing the distance at 110 kilometers per second, the human instinct is to treat this as a geographical challenge. We look at the void the way ancient mariners looked at a dark ocean, assuming that with enough time, enough resources, and a sturdy enough vessel, the crossing could eventually be made. This is a fatal misunderstanding of how the physical universe operates. The distance to our nearest galactic neighbor is not an engineering problem waiting to be solved by more efficient propulsion systems or larger fuel tanks. It is a fundamental paradox woven into the very architecture of reality. It is a structural barrier that physically prohibits our passage, enforced by cold mathematical laws that are entirely indifferent to human ambition. To understand the true nature of this barrier, we must confront the absolute tyranny of the speed of light. In popular culture, light speed is often depicted simply as a very fast velocity, a throttle setting to be achieved on a dashboard. But in the uncompromising equations of physics, the constant c is something far more restrictive and terrifying. It is the ultimate speed limit of causality itself. It is the maximum allowable rate at which information, energy, or matter can propagate through the fabric of space-time. Imagine the universe as a vast, low-level operating system. The speed of light is the absolute clock speed of the processor. You cannot execute a command, move a physical data packet, or trigger a local event faster than the hardware inherently allows. If you attempt to force an object with mass to accelerate toward that absolute limit, the universe fights back with mathematical violence. As a spacecraft accelerates, its kinetic energy naturally increases. But according to the relentless logic of special relativity, as you begin to approach the speed of light, that added energy no longer translates cleanly into forward velocity. Instead, the universe demands a tax. The energy begins to convert directly into mass. The faster you push the ship, the heavier the ship becomes. It is an asymptotic nightmare. To push a single microscopic electron to exactly the speed of light would require an infinite amount of energy. To push a manned spacecraft of any significant weight to that speed would require more energy than exists in the entire observable universe. You are not fighting a lack of fuel or a failure of engineering. You are fighting the foundational geometry of the cosmos. But let us assume, for the sake of exploring the paradox, that humanity eventually achieves the impossible. Imagine we engineer a theoretical antimatter drive capable of sustained, perfect acceleration. We build a massive ship that accelerates at a constant rate of 1 g, mimicking the comfortable gravitational pull of the Earth, pressing the crew firmly to the floor of the vessel. For the first few months, the journey seems almost pedestrian. The engines burn, the velocity compounds. But as the ship continues to accelerate into the deep void, crossing a significant fraction of light speed, the mathematics of the cosmos reveal their most cruel and isolating trick. As you move faster through space, you physically move slower through time. This is not a psychological illusion, nor is it a mechanical failure of the clocks on board. It is a literal, measurable deformation of reality known as time dilation. Time is not a constant ticking metronome that governs the entire universe evenly. It is a flexible, deeply local dimension, intimately tied to how fast your specific frame of reference is moving. From the perspective of the crew aboard the accelerating ship, the continuous thrust begins to warp the geometry of the universe around them. Because of the extreme effects of relativity, the physical distance between the Milky Way and Andromeda actually begins to contract in front of them. The 2.5 million light-year gulf shrinks. For the crew, the journey to the Andromeda galaxy would not take millions of years. By accelerating at a constant 1 g and flipping the ship at the halfway point to decelerate, the crew would arrive in the Andromeda system in just under 29 years of their own subjective ship time. It sounds like a magnificent triumph of human defiance, a single human lifetime to cross the great abyss, but the universe demands a terrifying, irreversible toll for the manipulation of space-time. While 29 years have ticked by on the biological clocks of the crew, the rest of the universe has not waited for them. Outside the hull of their ship, bound by the rigid, objective clock of the static void, over 2.5 million years have elapsed. If that crew were to somehow turn their ship around and make the exact same 29-year return journey back to Earth, they would not be coming home. They would return to a solar system that is over 5 million years older than the one they left. The Earth they knew, the civilization that built them, the very species they belonged to, would be completely erased by the relentless grinding of deep time. Continental plates would have completely rearranged the face of the planet. The sun would be subtly hotter, gradually burning away the remnants of the biosphere. The crew would survive the physical crossing, but they would be permanent exiles in time, severed from everything they ever loved and understood. The void does not just separate us in physical space, it physically traps us in our own era. To cross the deep ocean is to commit chronological suicide, yet time dilation is merely the psychological horror of the crossing. The physical reality of traveling at relativistic speeds introduces a barrier of pure kinetic violence. We previously defined the intergalactic vacuum as a freezing, empty expanse, containing perhaps a single hydrogen atom per cubic meter. At the slow, crawling speeds of terrestrial orbital mechanics, this sparse gas is an imperceptible ghost. But physics dictates that there is no absolute frame of reference. If you are moving at 99.9% the speed of light, you are not moving through a stationary mist of hydrogen. From your perspective, that freezing mist is slamming into the front of your spacecraft at 99.9% the speed of light. At these extreme relativistic velocities, the kinetic energy of a single solitary proton is magnified to cataclysmic levels. When you drive a car through a heavy fog, the water droplets splash harmlessly against the windshield. When you fly a massive spaceship through the intergalactic medium at near-light speeds, every individual atom of hydrogen strikes the hull with the energy of a high-powered particle accelerator. It is a continuous, relentless bombardment of ionizing radiation. The metal of the ship would not simply heat up from friction. It would be physically transmuted and destroyed at the atomic level, shedding deadly showers of secondary radiation, immediately flooding the crew compartments with lethal, sterilizing doses of gamma rays and high-energy neutrons. And the trace amounts of hydrogen are not the most terrifying obstacle. The seemingly empty void is entirely saturated with the cosmic microwave background. This is the faint, fading afterglow of the Big Bang itself, a sea of low-energy photons that permeates every single cubic inch of the universe. To a stationary observer, These photons are harmless microwaves, entirely invisible and carrying almost zero energy. But as a spacecraft accelerates toward Andromeda, a physical phenomenon known as the relativistic Doppler effect takes a deadly hold. The light waves in front of the ship are radically compressed. The harmless low-energy microwaves are heavily blue-shifted. As the ship pushes harder against the speed of light, those microwaves are compressed into visible light, then into searing ultraviolet, then into penetrating X-rays, and finally, into hard, sterilizing gamma radiation. The faster you try to cross the void, the more the void actively tries to incinerate you. The empty space in front of the ship transforms into a blinding, solid wall of lethal radiation, a physical manifestation of the universe's resistance to our passage. There is no shielding material known to material science, no magnetic deflector hypothetical enough in our current understanding to withstand millions of years of sustained gamma-ray bombardment created entirely by the ship's own velocity. The barrier is absolute. We are confined to our local galactic archipelago, not merely by distance, but by the physics of absolute friction in an ostensibly empty vacuum. Faced with this impenetrable wall of light-speed travel and kinetic destruction, theoretical physicists refuse to concede defeat. If we cannot safely move through the space, the mathematics demand we ask a radically different question. Can we move the space itself? This is where the mechanics of reality begin to fracture, exposing the deepest, most frustrating schism in all of modern science. To attempt to cheat the distance to Andromeda, we turn away from traditional propulsion and look toward the elegant, sweeping mathematics of Albert Einstein's general relativity. Einstein taught humanity that space-time is not a fixed, rigid stage on which the events of the universe play out. It is a flexible, dynamic fabric. It can be bent, stretched, twisted and folded by the presence of mass and energy. This is how gravity fundamentally operates. A massive star like our Sun creates a deep depression in the fabric of space-time, and the planets roll along the curved walls of that depression in perfectly stable orbits. If space-time can be warped by the natural existence of mass, the theoretical leap is to wonder if it can be aggressively warped by human engineering. In 1994, a theoretical physicist named Miguel Alcubierre published a paper detailing a mathematical solution to Einstein's field equations that permitted faster-than-light travel without ever violating the local speed limit of light. The concept, widely known as an Alcubierre warp drive, proposes a mechanism of breathtaking, terrifying audacity. Instead of accelerating a ship through the void, which triggers the deadly traps of time dilation and radiation, the ship remains entirely stationary within a small, localized bubble of perfectly flat space-time. The drive mechanism then violently compresses the fabric of space immediately in front of the ship, while simultaneously expanding the fabric of space behind it. Imagine a surfer floating on a calm ocean. The surfer is not paddling fast enough to cross the Pacific. Instead, the surfer is catching a massive, towering wave. The water in front of the wave is drawn up, and the water behind the wave pushes forward. The surfer simply rides the physical deformation of the surface. An Alcubierre drive would surf a wave of highly distorted reality, traversing the distance to Andromeda at millions of times the speed of light, while the crew inside the bubble experiences absolutely zero acceleration, zero kinetic bombardment, and zero time dilation. The equations balance. The tensor mathematics of general relativity allow this bizarre structure to exist on paper. It is a flawless, elegant solution. But it is exactly here that the universe reveals its final, most impenetrable barrier. To physically construct the Alcubierre metric, to violently curve space in that specific, highly aggressive manner, requires a massive concentration of something physicists refer to as negative energy density. To understand the absurdity of negative energy, you must understand that the vacuum of space is not a zero state. Even in the deepest, darkest expanse between the Milky Way and Andromeda, empty space is boiling with microscopic quantum energy. In classical physics, energy is a strictly positive quantity. You have energy or you have exactly zero energy. You have a mountain or you have completely flat ground. But the mathematics of the warp drive require you to dig a bottomless hole into the completely flat ground. It requires an energy state physically less than nothing. It requires matter that possesses negative mass. If you were to push a bowling ball made of negative mass away from you, the physics would dictate that it accelerates backward, directly into your hand. This is where the grand, sweeping geometry of general relativity violently collides with the chaotic, microscopic world of quantum mechanics. According to the standard model of particle physics, macroscopic negative mass does not and cannot exist. The quantum laws that govern atoms, quarks, and fundamental forces violently reject the concept of large-scale negative energy. We are trapped in a profound intellectual deadlock. General relativity provides the brilliant architectural blueprints for a bridge across the galactic abyss. But quantum mechanics flatly refuses to supply the necessary building materials. The two most successful, rigorously tested pillars of human knowledge are fundamentally incompatible when applied to the extreme mechanics required to cross the void. The result is a deep, lingering frustration in the scientific community. The universe is taunting us with mathematical possibilities that it physically and stubbornly forbids us from ever executing. But the deepest, most terrifying paradox of our relationship with Andromeda has nothing to do with our inability to travel there. It has to do with what the void itself is actively doing while we stare at it. We have established that Andromeda is the great exception to the cosmic rule. It is blue-shifted. The gravitational tether between our two massive spirals is overpowering the background mechanics of the universe, pulling us toward an inevitable, slow-motion collision. But this local gravitational dominance severely blinds us to the apocalyptic reality unfolding just beyond our immediate cosmic neighborhood. If we look past the local group, past the Virgo supercluster, out into the deep, incomprehensible expanse of the greater cosmos, the universe is not just expanding. The expansion is accelerating. The void is violently growing, driven by a repulsive, invisible force that astrophysicists refer to simply as dark energy. Dark energy is arguably the most profound and terrifying mystery in modern science. We do not know what it is. We do not know where it comes from. We only know what it does to the architecture of reality. It acts as a relentless anti-gravity field woven into the very fabric of the vacuum itself. As space expands, more vacuum is created. As more vacuum is created, there is a greater volume of dark energy, which causes the expansion to accelerate even faster. It is a runaway, compounding physical crisis with no known mechanism to stop it. The galaxies outside our local group are being aggressively dragged away from us. Because the expansion of space itself is not limited by the speed of light, distant galaxies are receding from our perspective at speeds that completely defy causality. There is a spherical boundary surrounding us, a cosmic event horizon, where the expansion of space reaches exactly the speed of light. Any galaxy pushed beyond that horizon by dark energy is permanently erased from our reality. The light it emits can never, ever reach us, because the physical space between us is stretching faster than the photon can possibly travel. This forces a horrifying realization about our future. When Andromeda finally crashes into the Milky Way billions of years from now, when the night sky of whatever world we inhabit is ablaze with the chaotic, violent birth of a new elliptical supergalaxy, the observers of that distant era will be utterly, terrifyingly alone. By the time our two galaxies fully merge into one colossal, stable structure, dark energy will have ripped the rest of the observable universe entirely beyond the cosmic horizon. The brilliant, sprawling superclusters of galaxies that we photograph today, the magnificent webs of starlight that define the cosmos, will be completely gone. The astronomers of the far future, born on some distant world within the merged core of the Milky Way and Andromeda, will look through their most powerful telescopes and see absolutely nothing. They will see a universe consisting entirely of their own local galaxy, surrounded by an infinite, static, perfectly black void. They will have no evidence of the Big Bang. They will have no evidence of cosmic expansion. They will have no physical way of knowing that billions of other galaxies ever existed. The entire history of the cosmos will be physically and permanently erased by the accelerating vacuum. We are living in a temporary, highly privileged window of time. an era where the universe is still dense enough to show us its staggering scale, yet old enough for us to mathematically understand it. We stare at Andromeda, tracking its relentless approach, fully aware that it is the last dying ember of cosmic interaction we will ever experience. The void is not just a distance to be measured or a barrier to be crossed. It is an active, aggressive mechanism, systematically dismantling the architecture of the cosmos, burying the evidence of creation behind an impenetrable wall of darkness. And as the mathematics of the void continue to unfold, we are left to confront a reality far more unsettling than mere isolation. The realization that the universe is actively deleting its own history forces us to confront a terrifying consequence about the nature of our own existence. We are not merely trapped in physical space. We are trapped in a fragmented, shattered timeline. The human mind clings desperately to the concept of now. We synchronize our watches. We execute global financial trades in microseconds. We coordinate our entire civilization under the strict assumption that a universal present tense exists. But the 2.5 million light-year gulf to Andromeda proves that this universal now is a localized hallucination. It is a cognitive bias, a biological comfort born from living on a small, dense rock where the speed of light feels instantaneous. Step outside the atmosphere of Earth, and the present tense disintegrates. The cosmos is not a shared, simultaneous experience. It is a necropsy of delayed information. When you look at Andromeda, you are not observing a physical location. You are reading a decaying archival document. To understand the severity of this delay, imagine uncovering a sealed letter buried deep in the frozen mud of an ancient battlefield. The ink is faded, the language is archaic, but it outlines a desperate plea for reinforcements. You are holding the physical evidence of a crisis, but the crisis itself resolved into dust and bone thousands of years before you were even born. Your knowledge of the event is perfectly accurate, yet completely useless. You cannot respond. You cannot intervene. You are simply a passive witness to a ghost. This is the exact, unyielding nature of our relationship with the wider universe. Every telescope ever built is essentially a microscope pointed at a cadaver. If a hyper-advanced civilization in the Andromeda galaxy were to harness the power of their central black hole today, igniting a beacon of unimaginable energy to signal their presence to the void, the light of that beacon would begin its agonizing silent crawl. It would travel for 2.5 million years. By the time that signal finally washed over the Earth, our sun might be entering its late, volatile evolutionary stages. The oceans might be boiling. The biological lineage of humanity would be entirely unrecognizable or completely extinct, and the reverse is equally terrifying. Suppose that exact same civilization is pointing their own immense optical arrays at the Milky Way right now. They are meticulously scanning our spiral arm, searching for the delicate chemical signatures of biology in the atmospheres of distant planets. When their instruments finally focus on the exact coordinates of our solar system, they do not see our sprawling orbital satellites. They do not see the glow of our nocturnal cities or hear the chaotic radio chatter of our civilization. Because of the cruel latency of the void, they are looking at the Earth as it was 2.5 million years ago. They see a freezing, volatile planet, locked in the ruthless grip of the Pleistocene Ice Age. They see crude hominids shivering in the shadows of caves. They observe a world entirely devoid of technology, mathematically write it off as a primitive, silent rock, and pivot their instruments toward another sterile star. We are invisible to them, and they are invisible to us, not because we are intentionally hiding, but because the architecture of space-time strictly forbids simultaneous contact. This temporal isolation provides a chilling mechanical answer to the Fermi paradox, the deeply unsettling contradiction between the high mathematical probability of extraterrestrial life and the deafening silence of the universe. We expect a crowded cosmos to be loud. We expect to see the engineering signatures of godlike species restructuring their galaxies. But the sheer volume of empty space acts as an absolute physical quarantine. Their civilization could rise, map their local star cluster, compose symphonies of profound beauty, exhaust their planetary resources, and quietly go extinct, all within the span of a few 100,000 years. In the grand, unfeeling calendar of the cosmos, 100,000 years is a microscopic flicker. If that entire civilization's lifespan does not perfectly align with the transit time of light across the void, their existence is permanently lost to the dark. The universe is likely filled with the silent ruins of dead empires, all separated by oceans of time so vast that their desperate distress signals simply pass each other in the night, unrecognized and unanswered. We are screaming across a canyon where the echo takes millions of years to return, long after the voice that shouted has turned to ash. This forces a radical, uncomfortable shift in how we perceive our own importance. For centuries, theology and philosophy have fiercely argued that human consciousness is the ultimate, crowning pinnacle of creation. We like to believe that the universe is a vast, beautiful stage designed specifically for us to observe it and find meaning within it. But the terrifying mechanics of the intergalactic void suggest a reality that is far more indifferent. We are not the masters of the cosmos. We are the victims of cosmic timing. Astrophysicists refer to our current epoch as the stelliferous era, the time of stars. It is an incredibly brief, highly privileged window in the life cycle of the universe. We happen to exist in a narrow, fragile margin of time where the universe has cooled enough for complex matter to form, but has not yet expanded enough to rip that matter permanently apart. We are living in the golden twilight of observability. Because dark energy is relentlessly accelerating the expansion of space, the observable universe is literally shrinking around us. The cosmic horizon is closing in like a tightening noose. Every passing second, the distance to the farthest galaxies stretches beyond the speed of light, and they slip over the edge of physical reality, permanently vanishing from our sky. The amount of information available to us is strictly finite, and it is bleeding away into the dark at a terrifying rate. We are the universe waking up just in time to watch the doors lock and the lights go out. Think of the profound existential weight carried by the astronomers and physicists of our era. The data we gather today, the deep field photographs of the Virgo supercluster, the microwave maps of the Big Bang's fading afterglow, these are not just scientific curiosities. They are the final, definitive historical records of a dying paradigm. We are frantically documenting the existence of a grand, interconnected cosmos that will soon be physically erased by the expansion of the void. When we look at Andromeda, we are not just looking at a neighbor. We are looking at a lifeboat. It is the only significant structure in the entire universe that is actually coming toward us, fighting the relentless, overwhelming tide of cosmic expansion. Every other major galaxy is fleeing into the dark. Andromeda is the only system that will remain mathematically visible to our distant descendants. It is the final, meager inheritance of a bankrupt universe. But this lifeboat offers no actual salvation. The slow-motion collision will not bridge the gap of consciousness. It will only merge the graveyards. Even when our two massive galaxies finally intertwine, when the gravitational tides rip our respective star systems apart and forge a new, chaotic elliptical core, the fundamental rules of the void will remain unbroken. The physical space between the individual stars will still be staggering. The latency of light will still enforce its strict biological quarantine. We will share a unified galactic neighborhood, but we will never, ever share a simultaneous reality. The realization that all of this, the billions of ancient stars, the sprawling, glowing nebulas, the slow, violent collision of supermassive black holes is happening in absolute, unbroken silence, completely devoid of intrinsic meaning or narrative purpose, strips away the final protective layers of human ego. We are forced to confront the chilling mathematical possibility that consciousness is not a triumphant feature of the universe. It is a rare, localized defect. Her brief, chaotic chemical reaction, occurring on a temporary speck of dust, entirely irrelevant to the cold, grinding machinery of space-time. The universe does not know we are here. It does not care that we have calculated the exact distance to Andromeda. It does not care that we fear the dark. The void is not a malicious entity plotting our demise. It is simply a physical absolute. It is a thermodynamic certainty that slowly, patiently dissolves complex systems, tearing them down into isolated, freezing atoms. our entire civilization, our recorded history, our art, our orbital mechanics, it is all just a microscopic rebellion against the second law of thermodynamics. A temporary, fragile fortress built of order, surrounded by an infinite silent siege of entropy. And the siege is completely unbreakable. No matter how perfectly we refine our equations, no matter how deeply we pierce the dark with our silicon sensors and polished mirrors, we cannot alter the fundamental architecture of the trap. We can only measure its impossible dimensions with agonizing precision. The ancient light from Andromeda continues to fall onto our lenses, a cold, relentless rain of dead information. It tells a story of a universe that is vast, violent, and deeply infected, with an emptiness that cannot be quantified by mere miles or kilometers. It is an emptiness that permeates the very concept of time itself, separating the birth of a photon from its death by millions of isolated years. Tonight, when the Earth rotates away from our local star and the scattered blue light of the atmosphere bleeds out into the vacuum, walk outside. Stand in the dark and look up. Find the fractured geometry of Cassiopeia. Look just below it. Find that faint elongated smudge of pale light resting against the freezing black canvas. You can no longer look at it with the naive comfort of our ancestors. The optical illusion of the celestial sphere has been mathematically shattered. You are no longer looking at a painted dome, and you are no longer looking at a neighbor. You are staring directly into the terrifying, hostile architecture of the abyss. You are looking at a phantom, a decaying transmission from a prehistoric era, launched across the dark long before humanity understood how to spark a fire to keep the shadows at bay. Armed with the cold logic of the distance, you are forced to carry the crushing weight of our true scale. We spend our brief, frantic lives constructing sprawling networks of steel and fiber optics, rewriting the genetic code, and splitting the atom, desperately trying to convince ourselves that we have mastered the physical world. We declare ourselves the architects of destiny, but the 2.5 million light-year gulf to Andromeda stands as the ultimate impassive monument to our absolute insignificance. It is a prison constructed entirely out of nothingness. We are permanently confined to our microscopic grain of sand, not by physical walls, but by the relentless, suffocating tyranny of empty space and the absolute speed limit of causality. The human condition is defined by an agonizing need to connect, to be acknowledged, to leave a permanent scar on the fabric of reality. We broadcast our high-frequency radio signals and launch our heavy metal probes out into the dark, hoping to strike a resonant chord in the deep. But the void does not negotiate with biological ambition. It enforces a strict mathematical quarantine. The vast latency of the universe ensures that every message we send is nothing more than a localized, dying echo. The cosmos is not a grand, interconnected dialogue. It is a deafening, entropic monologue spoken in the brutal mechanics of gravity, orbital decay, and absolute vacuum. We are permitted to listen to the dying light of the past, but the equations of reality strictly forbid us from ever answering back. Billions of years from now, the slow-motion collision we are tracking tonight will finally reach its violent, magnificent climax. The sky of whatever ruined world remains here will burn with the chaotic light of 1 trillion displaced stars as our two massive galaxies violently tear each other apart in the dark. But there will be no human eyes left to witness the fire. The fragile biological anomaly that briefly named the constellations and measured the light will have long since dissolved back into the frozen atomic dust of the intergalactic medium. Our sprawling cities, our vast digital archives, our desperate philosophical struggles, none of it will leave a measurable ripple in the fabric of space-time. The universe will simply continue its blind, mechanical clockwork. The supermassive black holes will merge, the dying stars will detonate, and the accelerating vacuum will silently erase the rest of creation from the sky. The light will just keep traveling through the freezing, expanding dark, perfectly indifferent to whether or not there is anyone left to capture it. Look into the void,